Hello everyone, and welcome to today's webinar. Today I want to talk about tolerances. More specifically, the tolerances of the Raise 3D Pro 3 and a little bit of the E2CF. What are tolerances? And why are they important? Well, it is basically how much extra space you need to allow for when designing parts. Say you're designing a speaker housing for a Bluetooth speaker, and you want to print that with your Raise 3D Pro 3. Well, you're going to have a top half and a bottom half, and they somehow need to fit together. So most likely, you'll design something like a peg that goes into a hole or slot on the bottom half, anything like this. But what if, after printing, the hole that you designed is too small for the peg to slot into? Well, that would be due to bad tolerances. And we wanted to know just how good the tolerances on the Pro 3 are. Recently, we saw a video by MakerBot where they printed a tolerance test with their printers in order to figure out the exact same thing. So we figured we'd do the same with a Pro 3. So we went and we started off with regular Raise 3D PLA. And now I can explain this tolerance test a little more. So basically what we did is we printed this. Let's hope the camera focuses properly on this. There we go. So each one of these circles, or the first circle, is 10 millimeters in diameter. And this first little square is 10 millimeters in side length. And then as the holes move on to the right side, they get bigger. And they get bigger by the amount denoted here. So the first one is exactly 10 millimeters. The second one is 10.05, 10.1 millimeters, 10.15, 10.2, and so on. So they get progressively bigger. And at the same time, we printed a square and a round peg. And these are exactly 10 millimeters in diameter or 10 millimeters on the side. And then what we do is we take this little thing that we printed and our pegs and we try to find which one they slot into. And it turns out that on the Pro 3, with the Raise 3D red PLA, the square block fits right into the 0. So it's exactly 10 millimeters. And then we can try with the round peg, and we start off with a 0. That one's a bit tight. I could probably force it, but then I can never get my Bluetooth casing, my speaker housing, apart again if I need to repair something. So I try the next one, and 10.05, voila, it slots right in there. Of course, as I keep going, it just keeps getting looser, and at this point, you can see that if I went with 10.2, it would be so loose that my part would just slide right out again. That's not something I want either. So using this tolerance test, I can now know that if I want a round peg to fit properly into a round hole that I designed for my part, I would need to make that hole 10.05 millimeters in diameter if my peg is 10 millimeters. That's essentially the basis of this tolerance test, and we've already seen how well it works with the Raise 3D PLA. So we wanted to know, does it work with other PLAs as well? So we printed with Polyterra by Polymaker, one of the more popular filaments these days. And what do you know? It is the exact same result. Can't get too close to the camera, else it struggles with focusing, but you can see, once again, the round peg in the hole for 10.05 millimeters and the square one in the one for 10.0. So this already looks really good. So now we had it with 2 PLAs. Why not try a third, this time a little bit pricier? Let's go for GreenTech Pro. And we were astounded to see that this time even the round peg fit into the 10.0 hole. A really impressive result that actually surprised us as well. So we couldn't quite believe it, so we printed it again. And this time around, same material, same printer, same settings. We had a slight deviation. Once again, the round peg fit into the 10.05 hole. So this seems to be the minimum we can expect because we've now had it across 3 different PLAs and it always came out exactly the same. But occasionally, the printer might yield even better results going all the way down to the 10.00. Really impressive stuff. But it would be boring if we just ended there, because why not stress test the printer a bit? Each one of these tests took around 10 hours to print. So we figured, hey, that's a little bit long. Let's speed it up a bit. So for the last one, after the print had started, On the display of the printer, we just went into the Tune menu and then set the feed rate to 150%. So whenever possible, considering acceleration and the like, the printer would try to print at 150% the speed of the profile that we used. By the way, the slicing profile for this was the very basic profile that is included in IdeaMaker for the 0.1 millimeter layer height. Yeah, so the fine profile or whatever it was called, or high quality, that was already included in IdeaMaker. We changed nothing about that profile. We just went and printed with it. So now we increased the speed to 150% of the feed rate, made it print faster, and the result stays the same. This is due to the redesigned and light printhead that the Pro 3 has. It needs to move so little weight around that it can actually print faster than the profile recommends you to without losing any tolerance or accuracy. So a very, very impressive result here from the Pro 3, and mostly due to this really rigid frame that we've already come to know and love from the Pro 2, but with all the added benefits of the Pro 3. We've got the flexible build plate, we've got the much lighter and redesigned printhead, and if we ever should run into an issue, we could just swap the hot end assembly very, very easily. So, once again, Pro 3 yielding exceptional results, even when printing faster than designed. Now we get to the other printer I have here, the E2CF. Now this printer is specifically designed to print fiber reinforced materials. And fiber reinforced materials have a number of advantages. First, the surface actually looks and feels quite smooth. Next, the parts are stronger. Well, because there's fibers reinforcing these materials inside. And the E2CF is specifically designed for these types of materials that are far more abrasive than regular plastics, such as PLA that we talked about before. So on this one, there is a redesigned printhead with hardened materials inside so as to resist the wear and tear of abrasive materials. Same goes for the nozzles that are installed on the printer. They are designed to last long, even when printing fiber reinforced filaments. So then we went and printed the same tolerance test on this printer as well, with P812 reinforced with carbon fiber. And the result is not as good as on the Pro 3. Why? Because even though the surface feels smooth, it actually is a bit rougher than the regular PLA. On top of that, when printing with fiber reinforced materials, stringing and lots of retractions can lead to some issues. So on these, we have tiny little protrusions on the inside of the holes that make it more difficult to push the peg inside the hole. But even with these limitations, we made it so that both the square and the round peg fit into the 10.15 millimeter hole. So even here, even with the more difficult material and like slight protrusions on the inside, the accuracy and tolerance is still good enough that we only need to expand our 10 millimeter hole by 0.15 millimeters. Once again, really impressive. And honestly, considerably better than a large number of other printers and/or competitors. So, that's what I had to say about the tolerance test. It should give you an idea of how this whole thing worked, what we did, and what these two printers can actually accomplish when put to the real test. I hope you liked this content. If you want, I'll put a link to the part that we printed here, this tolerance test, down below in the video description. Please do print one off your own and let us know what the results are. What printer do you have at home? What kind of results can you achieve? Can you make it to the 10.00 hole with better settings? Let us know. And so I hope that you liked today's webinar and that this was interesting to you. And if it was, please do consider subscribing to the channel so you get notified the next time we go live. And so you don't miss any of our content surrounding 3D printers and 3D scanners. Thank you very much for watching. That's all I have for today, and I hope I'll see you next time.